Hello.
How's it going, Professor?
Great. Good. Thank you. How are you?
I'm fine.
All right. We'll get started in a couple of minutes. All right, guys. It's about 1:30. So what I'd like to do is go ahead and do some exercises in worksheet 2. I did send you this morning an announcement. And in that announcement, you saw the worksheet with the solutions. I don't know if you had any time to look at it, but we'll go over it here in class in our Zoom session. Okay, so let me open it up here. All right, and okay, let's see. Let me do it this way. All right, can you all see this?
Yeah, we can see it.
Okay. All right. This problem here is the frequency table that I showed you on Monday, where researchers have gathered data. And this data set is displayed not as a list of data values, but rather as a frequency table. In other words, the data have been binned into classes that the researchers have chosen as their bins, as their classes. So they've established 6 classes here. And in these 6 classes, all 150 of the values have been binned into one of these classes, right? And only one. Okay. So the difference in this description of the frequency table is that now I want to talk about the midpoint of the interval. So I have a new column here, which is called X, and X will be the midpoint. And what we'll do is we'll estimate the sample mean of this frequency table using the midpoint, the frequency column, and the sample size n. And first what I'll do is give you a formula, and then I'll explain why the formula is a good estimate. Okay, so here's our formula, and so our sample mean is X bar. The bar is not, there's a typo here. There should be a bar above that X. Okay. This formula for the mean based on a frequency table is given to you in your textbook. Some of you may have already read chapters 1 and 2 and saw that you could estimate the mean of a distribution using a frequency table. Of course, if you have the data, you can simply add the values up and divide by n. That would give you the sample mean. But we don't have the data values here. So what we're going to do is create an estimate based on the midpoint of the interval. So let's go to the frequency column here and notice that 26 of these values fall in the interval between 0 and 2 hours. And we don't know the precise values of those 26 values, do we? All right, that's not been told to us. But we do have what's called a midpoint, and that is, it's just the arithmetic midpoint of this interval. So the interval from 0 to 2, its midpoint is 1. The midpoint in the class 2 to 4, the midpoint is 3, and so on. So as you inspect this column that says midpoint, you'll notice that the midpoint is simply the center of each of these intervals. Now here's what we're going to do. We don't have these 26 values in the first class. We don't have these 30 values in the second class, and so on. So what we're going to do is substitute the midpoint of the class for a data value in the class. And then we're going to add up that data value like we would if we had the real data. And we'll add it up 26 times. So think of your mean now as 1 plus 1, 26 times, plus 3 plus 3 plus 3, and so on, 30 times. And keep on doing that for all of the 6 classes. So here it is up here. Here's our formula. So we'll multiply the midpoint x by the frequency. And then when we're done adding all those products up, we'll divide by the sample size. Okay? So even though we don't have all the values in the first interval or the second interval and so on, we'll substitute these unknown values with the midpoint of that interval. And we'll multiply the frequency times the midpoint. That's as if we added if we added 1 to itself 26 times. Here it is, 1 times 26. And then we add 30 times 3 plus 5 times 49. So we go down these 2 columns, multiplying midpoint times frequency. And in the numerator of that ratio, we get 732. You could take out your calculators and then calculate that sum of products and then divide by 150. Okay? And then when you do that, you get 4.88. So 4.88 then is our estimate of the sample mean. And we've stolen one there, haven't we? Because we don't have the data. We just have this frequency table. And the frequency table is our way of estimating the sample mean using this formula up here. Midpoint of the interval times the frequency of the interval, plus midpoint of the next interval times the frequency of the next interval. And do that, see, here's the numerator here in our formula. And this formula is known as the estimate of the sample mean using the frequency table. Okay. So we get the value 4.88. It should be fairly close to the true sample mean if we had all the 150 data points. Okay. Because we know that the data is scattered randomly in this interval 0 to 2, and we'll use the midpoint as the estimate of each of those data points. All right? We'll ignore the relative frequency and the cumulative relative frequency columns. We computed those last Monday. What we're focused on is estimating the sample mean. Okay. And here it is. So the average amount of time that these sampled students played video games during the week was not quite 5 hours. It's 4.88. Okay, you see how we did that? So this is a very useful formula that shows you how you can estimate the mean using the frequency and the midpoint. And now we can go into StatCrunch and use our bar chart and calculate the distribution of the data using the frequency table here. And then the last question is, whereabouts is 4.88? Should be the center of the distribution because it's the sample mean. And then here you can see that it lies in this class here, and it looks like the center of the distribution. In other words, the center describes the typical value measured by the sample mean. So geometrically, let's call, for the moment, let's call the sample mean 5. It's 4.88, but you can see 5 is right here, okay? And that gives you the center, so-called center of the distribution. The median is probably more of the center of the distribution, right? You have just as many values above the median as below, okay? Any questions about the frequency table, estimating the mean from the frequency table, and then drawing a bar chart of these 6 classes where the x-axis is hours played in a week, and the height of the bar is the relative frequency. Okay, so this gives you a quick and handy view of the distribution, how the data is distributed, about its mean. And then it also has a standard deviation, right, which is the spread of the data. If the data is concentrated about its mean, the dispersion of the data is less, so the standard deviation will be less. Remember what the variance is? The variance is the sum of the square differences between the value in the data set minus its mean, okay, x bar, square that difference, add up all those square differences, and divide by n minus 1. That's our definition of the sample standard deviation, okay? And so we could also use this frequency table to estimate the standard deviation by subtracting each of these midpoints from its mean, squaring that difference, adding up those differences, and dividing by n minus 1. Not asking you to do that, but so, you know, in some cases we don't have the data. Typically we have it. If we don't have it, we can display it in a frequency table, or let's say if it's displayed in a frequency table, then we can calculate its mean, and we can calculate its histogram, which gives us a flavor of the distribution. All right. Now, the next example, any questions about number 1 here? I think all of these ideas are familiar to you now. Most of you have worked in your WebAssign assignments, and you've had to read and understand what these various statistics are and how to calculate them and how to calculate histograms. So this is probably a review for you. Okay. This one here is a slightly different flavor. Okay. We don't have data. What we're going to do is conduct an experiment and generate our data based on this experiment. Now, the experiment is tossing a coin 3 times. Why 3? Why don't I toss it once or twice or 10 times? Well, 3 is just for illustration purposes. There's no special magic about 3, but 3 is nice because we can list the outcomes of the sample space. That is, in tossing a coin 3 times, we get various random outcomes. All right. So if we toss the coin once, we might get a heads on the first toss. Follow it up with a second toss and notice that you might get a heads on the second toss. And then finally, on the third toss, you might get a third heads. So what we're going to do is list all the possible outcomes of the experiment, toss a coin 3 times. Okay. Now, use the multiplication rule that you learned in algebra for counting. If you have 2 outcomes on the first toss, heads or tails, 2 outcomes on the second toss, heads or tails, and then 2 outcomes on the third toss, heads or tails, in order to get all of the possible combinations of heads and tails, you would count up 2 times 2 times 2, which is 8. So you would get 8 possible outcomes from the 3 tosses, and I've listed them all here. Okay. Now the next thing I'm going to do is count the number of heads. We'll call that value, in the third problem, we'll call it x. Now, this value is very easy to calculate now that we've listed all of the 8 outcomes here in the experiment. Okay, now let me throw you a curveball. How many outcomes would there be in the experiment, in the sample space, if I toss the coin 4 times? Let's see, Drew, are you there? Hello, Drew? Now, you see with 3 tosses, you get 2 times 2 times 2, which is 8. How many outcomes would you get if you toss the coin 4 times? And these outcomes, excuse me, these outcomes are simply sequences of heads and tails. All right?
You would have 16.
16. All right, because again, using the multiplicative rule of counting, on that 4th toss, you have 2 more outcomes, and then you multiply the 8 times 2, and you would get the full list of 16, right?
Yes.
And in general, if you toss the coin n times, the number of such sequences of heads and tails would be 2 to the n. Right? If you toss the coin once, you get 2 outcomes. If you toss the coin twice, you get 4 outcomes, 2 squared. If you toss the coin 3 times, like we did here, you get 2 cubed, or 8. And then 4 times would be 2 to the 4th, which would be 16. All right, so there we have our experiment of tossing a coin 3 times. We've done a couple of things here. We've listed all of these 8 outcomes as sequences of heads and tails where the order matters, okay? HHH means that we toss 3 consecutive, we see 3 consecutive heads in the 3 tosses and so on. Now let's go to the second row and list or note the number of heads in the 3 tosses. So the title of this row is the number of heads. HHH, 3 heads. HH tails, 2 heads. H tails heads, 2. Tails heads heads, 2. Tails tails tails, 0. No heads in 3 tosses. And then 1 heads in 3 tosses in the 3 remaining outcomes. Okay, now let's go to number 3. In number 3, we let the random variable x be the number of heads in 3 tosses. It's a variable because it can be 0, 1, 2, or 3. It's random because we don't know what the list of 3 outcomes is going to look like. It just depends on chance. And typically we would say that the probability of a heads is a half. The probability of a tails is a half. We assume the coin is fair. Now, if we have a die has 6 faces, 1, 2, 3, 4, 5, 6. And if we toss or roll a die, any one of those 6 faces would be equally likely, right? We assume it's a fair die. It's not been weighted in any way to cheat. It's fair. So any one of those 6 outcomes would be equally likely. And so the probability of any one of those outcomes, 1 through 6, would be 1/6. Another way to think of the roll of the die would be to think of tossing a coin with the probability that you have a coin which has 6, let's say, faces to it. It's hard to imagine that, but the point is that you either get a 1, let's say an ace, on your roll of the die or not. Let's think of the event, roll an ace, which is a 1. That has probability 1/6. And then the probability of a tails would be you don't see an ace, which would be 5/6, right? That would be the complement. So you could also look at that scheme, that experiment. But here we have our coin, and there are 2 outcomes in the toss of a coin, heads or tails. And let's calculate the relative frequency of observing 0, 1, 2, or 3 heads in the 3 tosses. Okay? So here's a column. The first column is a list of the various values that the random variable can assume. 0, 1, 2, or 3. And then in this column, we've counted the number of times no heads occur. That's just 1 out of 8, right? Just this one here. So the 3 tails occurs once in the 3 tosses. So if x is 0, that means its frequency is 1. In contrast, we get exactly 1 head in these 3 tosses out here. Tails, tails, heads, tails, heads, tails, heads, tails, tails. So the number of times that we would see in this experiment exactly 1 head would be 3 times, these 3 instances here. Similarly, for 2, we get these 3 instances. So the variable x is equal to 2 has frequency 3. And then all heads occurs just once out of the 8 outcomes. So now we can define relative frequency as the frequency divided by 8. And there you have now a frequency, a relative frequency for no heads is 1/8, one head 3/8, two heads 3/8, and three heads as 1/8. And again, notice that these relative frequencies add up to 1. Okay. Now, how would we calculate the average number of heads in 3 tosses? We're going to do exactly the same thing as we did up here. The midpoint will now be the value x that the random variable takes. 0, 1, 2, and 3. Okay. So we'll use the same formula that we used in number 2, number 3, number 1. And we'll multiply the value x, which is the value of the variable. We'll multiply it by its frequency, and then we'll add those up. Okay. All right, and when we do that, we get this value here. The sample mean, again, this should have a bar over it, is equal to the value that the variable takes, x, times its frequency divided by n. So if we did that, you see up here in the numerator, we get 0 times 1 plus 1 times 3 plus 2 times 3 plus 3 times 1. Add those up, add those products up, you get 12. And then you divide by n, which is the number of outcomes in the experiment, or the number of samples in your experiment, and you get 12 over 8, which is 1.5. So the statistical average of the number of heads in 3 tosses would be 1 1/2. Okay. All right. Taylor, are you there?
Yes.
Okay, Taylor, if we toss a fair coin 4 times, what would be the statistical average of the number of heads in 4 tosses? Now, before you answer that question, remember, you could very likely see no heads. You could see 1, 2, 3, or 4. Those are the 5 outcomes. But on average, if we repeated this experiment a number of times and took the average number of heads that we saw each time, what would your average number be?
I'm not really sure.
Now remember, with 3, we just calculated the statistical average here, and we got 1.5. Okay? So, and you know that 1.5 is just half of 3, right?
Yeah.
So what would your guess be for 4?
2.
2. Yeah. Now, again, remember that you're not going to see 2 heads every time you toss the coin 4 times. You might see no heads. You might see 4 heads. But if you repeated this experiment a large number of times, you would probably estimate your mean to be 2. Okay. So we have the idea here that the statistical average is half of the number of tosses. Okay. So that's that's going to come up when we talk about the binomial distribution. All right. So if you toss the coin n times, you get 2 to the n outcomes. Toss the coin 5 times, 2 to the 5th is 32. And the statistical average number of heads that you would see in 5 tosses would be 2.5, right? And so on. Okay, let's go to the next problem here. And what we're going to do in this problem is draw a box plot. The box plot is nothing more than a box and whiskers. The box will be defined by the first quartile and the third quartile. That is, the width of the box will be the interquartile range, which is just Q3, which is our third quartile. Remember, third quartile is 75th percentile. First quartile is 25th percentile. And the median is the 50th percentile. The whiskers are the min and the max. So it's a very simple descriptive graph for the distribution of the data. If you look at the box, it shows the range of the interquartile. If you look at the max and the min, it shows you the range of the data. And then finally, the box plot will also have the median calculated, which gives you the center point of the data. How is the data distributed? Okay. Now again, in StatCrunch, we can calculate these statistics and plot the box plot. All right. And I think we have time here. Let me go to StatCrunch now. I don't have it up here. Let's sign in. And if you haven't opened StatCrunch before, it's really going to help you in your WebAssign homework. I've talked to a few of you about WebAssign, and I've demonstrated for you how to use StatCrunch. So what we're going to do is go ahead and use StatCrunch here to calculate our box plot. Now, I've explained how you calculate a box plot. You calculate the so-called 5-number summary, as your textbook calls it. It's the min and the max, Q1 and Q3, and the median. Okay, so let's do that. I'm going to need the data. So let me go ahead and type in the data into our spreadsheet. Now, there aren't too many values here, so bear with me. Well, there are 22 values. Okay, so I'm going to give the column here a title, and I'll call the data test scores. And then bear with me here while I type in these 22 values, and give me a heads up if I make a typo here. This is going to be slow, so bear with me. Okay. Okay, so far so good. All right, let's see if I can go a little quicker here. Hopefully this is my, oops. Let's see. 25.5, 45, 65, 68, 76, 78, 78. I left out a 78. Let me put it in right here. Okay. There we go. Okay. No harm done. We've got all of the first 11 values, and now the rest of the values. Let me go. So we've got another 81, 83, 84.5, 85, 88, 89, 90, 90, 98, and let's see, we've got another 98 here. Okay, I think that's correct. All right, so I've typed in the data in a column, and now I can go to my graph function and look at this, this list here. It's a whole potpourri of plotting functions. Okay. Some of you have already looked at this function, and you may have used it to calculate a histogram. We're going to calculate a box plot. So we'll mouse down to box plot, hit that, and now we get an action window. And it's asking us to select a column. Well, here's our column. So we select that. Notice that it appears on the right side there. And we'll skip over these options here. And I typically like to draw these plots horizontally. You can plot it vertically. Okay, the default is vertical. Let's plot it horizontal. I won't use outliers, so I'll uncheck that box. Let's go ahead and leave these blank. It's already going to give us the median, okay? And then we have some more options here where we can label the x-axis. Typically, we do label the x-axis here. Let's label it as test scores. That's our data. And there's no y-axis, is there? Okay. And now we can compute, and here it is. And you can adjust this, you know. And how did I get that? How did I get this plot into my document, into my worksheet? Before we do that, let's just inspect it here. Okay. And you can see that it gave us, it shows us, if we mouse over the box, you can see all of the 5 number summary, the min, the max, Q1, Q3, and the median. Okay. And notice that the line inside the box is the median, 81. Okay. All right, and then as I mentioned, you can copy and paste this into your document. All right. So I selected copy in options there in the graph, and then I hit Control click, and I can save the image or copy the image and then paste it right into my document. Okay. And in talking to you about your WebAssign, I noticed that some of you have already drawn box plots. You can draw these by hand, right? Because you know the 5-number summary. And the 5-number summary can also be given to us by summary stats. So if you wanted to plot this by hand yourself, you could plot your 5-number summary using summary stats. So I mouse over stat, I choose summary stats, and then my data is in test scores column. And then I'm going to, I need, let's choose N. That's not part of the 5-number summary, but let's just display it anyway. So we want the median. So I'm going to hit Control on my keyboard and then hit median. I'll come down here, select the max and the min. Again, I'm pressing Control or Command on my keyboard, on my Mac keyboard, before I click on the statistic. And then finally, the other two values, Q1 and Q3. All right. So there I've selected 5, the 5-number summary, and then I can compute those based on the column of data. And so here are the values, okay? And then you see they match up with the values given to you on your plot, okay? So in past courses where I've taught this, people that did not have StatCrunch, they were able to calculate these values by hand. You can calculate all of these statistics by hand using the proper formulas, and then use your ruler and pencil and plot out the box plot. Okay. Some of you may have done that already when you were using WebAssign. Okay. Any questions about using StatCrunch? I really encourage you to begin using StatCrunch. You'll see that it's very easy to learn how to use. And notice that there's a very nice help feature here. And if you look at videos, you'll see very, very detailed instructions, step by step, on how to calculate all of your statistical calculations. So in future worksheets, I will be using StatCrunch almost exclusively. All right, now, okay, so we'll end it there. I know you have other projects that you're doing, other classes. I didn't want to take too much of your time here. Now, is Monday, Friday a good time when I can ask you to join the Zoom session? Monday and Friday? And we'll keep doing these worksheets as preparation for your midterm exam. So be sure and log in. Okay, let me check the chats here. I think we've got some people on chats. Somebody says, Mondays I'm busy, but Fridays I'm free. Now, I'll always post the videos of these Zoom sessions that we have on Mondays and Fridays. So if you can't make it on those days, you can always check your announcements a couple days later if not sooner, and you'll see the video, right? Zoom is recording this session, and I'll go ahead and just edit it in YouTube and then post the link in your announcements, and so you can refer to it in Canvas. All right. Okay, guys, if there aren't any questions, we'll sign off. I'll make an announcement on Monday just to confirm our session on Monday. All right, any last questions, comments? Are we good? Okay, guys, have a good weekend, and we'll get together on Monday, all right? Bye now.
Thank you.
Thank you, bye-bye.